All right, this is for the juniors. Whoever is taking the ACT, I'm running through all of the rules of probability and how they work and the formulas for them, and just a couple things on the back side of this sheet. So there's that. All right, so the first thing that they talk about is the fundamental counting principle, and I give you two examples of fundamental counting principle, okay? They all involve multiplying the number of options together. So for the equation they have here, n is calculated by just taking those and multiplying them together, okay? The first example that I give of this is the easiest one. How many outfits can you have? So 6 shirts, 5 pants, 4 hats, 2 socks, 3 shoes. How many outfits can be made? You multiply them all together. So 6 times 5 times 4 times 2 times 3, and I don't know what that answer is. It is a really big number. It's like 720 maybe or something.
Yep, exactly.
Yes? Is it? No, it's not.
Yeah, it is.
Yeah, it is. 720 different outfits that you can make out of those options, okay? Right? Okay, but also the fundamental counting principle, which is still multiplying stuff together. How many passwords can be created, okay? And they're going to give us specifications. So, first of all, how long is the password? Does it say? 4 characters. So I always do 4 blanks, and then we just put how many combinations each one of those blanks can contain. So the first character must be a number. And how many numbers are there? 0 included. There are 10 numbers, 0 through 9. So this first number could be 10 different numbers. Okay. What do you mean? The next one, it says the rest of them are letters, but there's no repeats. So the second one has to be a letter. Then it could be 26 different characters, right? A through Z. But then it can't be repeating. So this could only be 25 and 24. And you're still doing the fundamental counting principle because you're multiplying the options together just like you were doing before. But you list them out, and there's even more combinations there. How many passwords could be created? 156,000 passwords. Now, if I want to create give more options, I could maybe not, or maybe allow the letters to repeat, or maybe I do all 4 letters, 26, 26, 26, 26, right? Or maybe I add 2 more characters onto the end, right? So I could do those options, and that would increase the number of passwords that could be created, okay? Now, this next one is permutation versus combination. Do you remember these rules? Permutation starts with a P, so does president. And if I'm doing president, vice president, secretary, the order matters because president is not the same thing as the secretary, right? Okay, so president and permutation order does matter. So NPR, and all you have to do is search for the N and search for the R and type it into your calculator and be done with it. Okay, NCR is committee. So if everybody is doing the same job or everything is equal and you're just trying to choose a certain number out of a group and everybody's doing the same job or all of them are equal, then it's going to be a combination. NCR, order does not matter. Okay, so let's look at the 2 different scenarios. How many ways can you choose a first, second, and third place out of 10 runners? Okay, is first place the same as third place? No, that would make me mad, right? If I got third place and then I was supposed to get first. First, second, third, not the same. So that's why this is a permutation. So it's NPR. But I'm choosing out of 10.
So 10 is first.
10 comes first, 3 comes second. I will tell you, if you try to type it into your calculator as 3P10, it will not let you. It will not let you type it in as 3P10. So you will know that you typed it in wrong. 10P3. On your calculator, the P button is under, if you have one of these, it's under math. So hit the math button on the main screen.
It's 720.
And you go over to PRB. So hit math and you go to PRB, which is like the 4th one over, and you go down to NPR. You see that? Anybody having troubles? So math button, go down to go over to PRB, go down to NPR. Yeah? That's where your factorial stuff is and all that good stuff. How many options do I have?
720.
720. 720 different ways of choosing first, second, third place out of 10 runners. Okay? As long as they're equal. We're assuming that they're equal, whatever. Okay? How many ways to choose 3 kittens to bring home from a litter of 10? Does it matter which kitten you choose first out of the 3? I want to choose the black and white one first, the yellow one next, and the one with a diamond on its face. Does it matter which one I pick up out of the litter first? They're all going to go home with me, right? So that's a combination. Now it's 10C3 in this case. It doesn't matter what order. I think it's like 120. Yes, 120? Perfect. Only 120 different combinations because we delete out the multiples. So if you have the same numbers like 10 and 3, the permutations will always be more than the combinations. Does that make sense? Because combinations, you're deleting out all the repeats. So given all of their numbers are the same, your N and R are the same, the combination will always be more than the permutation. Okay? Moving on. Now, the difference between and or multiplying and adding. Multiply, add, and, or. When you're doing and stuff, you are choosing two or more things. So I'm rolling a dice and flipping a coin. Or I'm choosing a marble and then choosing another marble. Okay? There's two different scenarios that you will run into with choosing two or more things. And either the events are independent from one another or dependent. Okay? Independent means that the two events are completely unrelated, meaning that you're rolling a dice and flipping a coin. One does not affect the other one. Or you're replacing the card back into the deck. So you will either see with replacement or you'll be dealing with two events that are completely unrelated with each other. Okay? And you just take their probabilities and you multiply them together. Multiply means and means multiply. You're doing two or more things. Okay? If you are not replacing, then that means you're going to subtract one from the bottom number, right? You're not out of 52 cards the second time, you're out of 51 instead. Okay, so here's your scenario. I'm using this for the same for this example and this example. Okay, so those are all 3 reds, 5 blue, 6 yellow, 8 green, 10 purple. Okay, those are the marbles that I'm given. How many total? We know you're going to have to do a total. 3, 5, 6, 8, 10.
What? No.
22, 32.
14.
Did you say 32? I got 32.
I thought you said
32 total.
I
Okay,
thought
when you see a list, automatically start adding them up because you know that you're going to have to do that at some point. You know you're going to have to add them up. And when they give it to you in a story problem, I list them off to the side as like 8 red, 5 blue, right? 6 yellow. I list them off to the side so I don't have to reread the paragraph. That's another good strategy when you're doing the ACT. Okay, list them off to the side so then you don't have to reread. Okay? All right, we want to know the probability of a red and a purple. So how many marbles am I choosing?
13.
No, how many marbles am I choosing? I'm choosing 2 of them, right? So that's why I am multiplying those together, okay? Choosing 2 marbles, I'm multiplying. How many reds are there?
3.
3 out of 32, and it says with replacement, so they're independent of one another. So I still have 32 marbles the second time, but I'm choosing a purple one, which is 10 out of 32. Then reduce if you can. 3 over 32 will not reduce. 10 over 32 will, though. If I divide both of them by 5, but divide both of them by 2, this is 5 and like 16. Anything else reduce? I don't think so. Then you multiply across the top. 3 times 5 is 15. What's 32 times 16?
512.
512? 15 over 512. Take 15 divided by 512 and give me a decimal. 0 point something.
0.029.
0.029. So however they list the answer. That might be something to check as you're reading the problem to begin with, is how they want the answer written. Okay? So whether they want a decimal, you know you have to go out to that far. Okay? All right, 2 reds at the same time. People get confused with that. 2 reds at the same time. They're like, how do I do that? At the same time is the exact same thing as pulling one out and then the other one out, but not replacing them. Does that make sense? Pulling 2 of them out at the same time is the same thing as pulling one out, then the other out, but not replacing them. So just do one and then the other, but not replacing, right? At the same time means that, okay? One and then the other, not replacing. So I have 2 reds that I'm pulling out. The first time I have a 3 out of 32 chance of pulling a red out, okay? Now, the second time, if I'm not replacing, I only have 31 marbles. How many of them are red?
2.
Only 2 this time. Most of the time you're going to end up just subtracting from the bottom number, but since I'm pulling 2 of the same color out, I have to subtract from the top number as well. Okay, so reducing, 2 and 32 will reduce. I can cross reduce 1 and 16, and I think maybe that is all I can reduce by. So on the top, 3 times 1 is 3. 16 times 31 is something.
496.
496. What's 3 divided by 496 as a decimal? 0 point. 0,
0.0060.
60. Okay, there you go. Really small chance of that happening. Okay, good. That was and. That was pulling 2 marbles out, or 3 marbles. It could be 3 marbles. Okay. The next one is the add scenario, and you only add when you're choosing one thing out of 2 different categories. You're adding those categories together, and this involves an or. So it's a fraction added to a fraction, or you will sometimes have the scenario where you have people that are repeating. Like if I'm choosing one person out of here and I want to know whether they are a girl or a basketball player. We have girls that play basketball, so you would be in both categories and we have to subtract you out because heaven forbid we have 2 of you, right? We don't want that to happen. We don't want multiples of you. Sorry, as much as I love you all. Multiples of you would be terrible. So we add the outsides together and subtract out the middle. Sometimes there will not be a middle if they are exclusive events, like having a junior and a senior. You can't be a junior and a senior at the same time, so there's nothing to subtract out, all right? Can't be in both categories. If I have a king and a 7, there is no card that is both a king and a 7 at the same time. But for inclusive events, I have cards that are kings and hearts at the same time. So I have to subtract those cards out when I add those categories together, okay? Here's your question. I'm drawing a card, and I want a 9 or, there's that word, an ace. A 9 or an ace, okay? An ace is like the number 1 in cards, right? Can you have a card that's both a 9 and an ace at the same time? No, right? How many cards are 9s?
Like
4 out of
52.
52. How many cards are aces? 4 out of?
52.
So what's the chances of me getting a 9 or an ace? 8 out of 52, which is, if I divide both of them by 4, it would be 2 over 13, I think.
Yeah, I know.
2 out of 13.
Yeah, 13.
2 out of 13. Or whatever that is a decimal.
So when it's an or, we add them.
When it's an or, you add. Exactly. Or you add. Okay? Now, in this scenario, a 10 or a red. Okay? So I'm going to do my Venn diagram here because here's my 10s, here's my red cards. Okay? In a deck of cards, how many cards are 10s? 4. How many cards are red cards? There's 52 total. 52 total. We're talking about red. They're reds or blacks? 26 because it's the diamonds and the hearts that are red. Okay, 13 of each suit, but 2 suits are reds. So 26 are reds. How many 10s are also red? 2. There's 2 in the middle that are also reds. Okay, so I do 4 over 52 plus 26 over 52 minus the 2 that I don't want to count twice. Okay? In this one, when you're adding and subtracting, don't reduce until the very end because you need a common denominator. 4 plus 26 is 30 minus 2 is 28 over 52. All right, divide them by 4 is like 7 over 13. Yeah, 7 over 13. Okay, and there's that. Okay, is this all kind of coming back to you? You remember this stuff?
Yep.
It's good to go over. Okay, go to the back side real quick. We're going to talk about area versus perimeter or circumference of these objects here. The first object, these are ones that they won't give you the formulas for. If they give you like the surface area of a cone and they want you to find the surface area of a cone, they will likely give you that formula. But these they will not. They will say, fend for yourself. Okay? You got to do it. All right, this first object is a square, right? How do you find the area of a square? Base times height. So in this case, since it's a square, it's 3 times 3. So its area is 9 inches squared. Okay, perimeter of the square. How do you find perimeter of this guy?
Add it up.
Add them all up. Or since all of them are the same, you could really just take 4 times 3, right? Because all 4 sides are 3s. 4 times 3, his perimeter is 12 inches squared. Or no, inches squared. Just inches, right? Perimeter is only in inches, not squared. Area is squared. Perimeter is not. Yeah? Okay. This guy is a rectangle. I'm going through this kind of fast. Are we doing okay? You're like, go faster, right? Okay. Rectangle. How do you find the area of a rectangle? Same thing. Base times height. So this guy's area is 10 inches squared. All right. Rectangle. Perimeter of a rectangle.
Add it up.
Add it up. How do you add those up?
2 plus 2 plus 5
Or two.
There's a couple ways you could do this to make it fast. To go fast, I would either do 2 plus 5 is 7 and then double that, right? Couldn't you do that? 2 plus 5 is 7 and 7 doubled because there's 7 here and 7 there, right? Or you could do 2 plus 2 is 4 and 5 plus 5 is 10. So 10 plus 4 is 14. Okay, however you want to do that, make it fast. Those are going to be ones where you save time, right? Try to add them up in such a way that you are trying to shave seconds off of your time so that you don't run out of time in the end on the hard problems, okay? All right, next one, circle. Area of a circle. You have to remember these. How do you find area of a circle? Pi r squared, and circumference of a circle is 2 pi r. How do you keep those straight? Area is always units squared, so the square goes with the square formula, right? Okay, so the radius here is 4 inches. So I'm going to do 4 in here. Let's do this. Pi times 4 squared. So 16 pi is going to be the area in inches squared, whatever that is as a decimal. They might leave the answer as 16 pi, right? They might not give it to you as a decimal. So make sure you look to see what they want the answer to be labeled in, okay? This guy is 2 times pi times 4, or 8 pi, just inches. That's the circumference of the circle, okay? Just the circumference. All right, happy with that? Okay, next thing, area of a triangle. How do you find area of a triangle? 1/2 the base times the height. Okay, what's the base of this guy? 6, so half. 6, and the height is?
4.
Not 5, it is 4. So half of 6 times 4, don't use a calculator to do that. What's half of 6?
Oh, that's
3 times 4 is 12. On these, do not use a calculator. Try to go in your head as much as you can because it will save time. Seriously, you can think faster than a calculator can. Okay? All right, then to find the perimeter. Whew, add up all the sides. What is this side over here? 5. Because we're going to assume that it's an isosceles triangle. It'll be drawn better. They will have it drawn better. So the perimeter is going to be 5 plus 5 plus